Hello, Math 5A students. Today we're going to talk about how to graph the basic exponential and log functions that we need to do for our FA for outcome number F8. So the problem that you'll get on the FA looks like this. We have 6 graphs functions that we need to graph, and they're all like the same every time, just like the other graphing fundamental outcomes that we had. And so we have e to the x, 2 to the x, e to the minus x, 3 to the minus x, and then 2 log functions, natural log and log base 2. So even though this starts with e to the x, I'm going to start with this y equals 2 to the x because I think it's easiest to work with when we're more comfortable with working with integers than with this number e. So for y equals 2 to the x, I'm just going to make a table of values to get started. Right, so when x equals 0, 2 to the 0, anything to the 0 is just 1. So we can plot that point. So that's 0, 1 on our graph. And then if I plug in x equals 1, we have 2 to the 1, which is just 2. So at x equals 1, this is 2. When x is 2, we have 2 squared is 4. So at 2, we have 4. It's up here. And some more values. So x and y equals 2 to the x. So if x is minus 1, we have 2 to the minus 1. So you have to remember the exponent rule. So 2 to the minus 1 is the same as 1 over 2. So, or here at minus 1, we're at 1/2. And similarly at minus 2, 2 to the minus 2 is 1 over 2 squared, which is 1/4. So at minus 2, we're at 1/4, and so on. So as we plug in larger negative values, the denominator is going to get bigger and bigger. So this is going to get closer and closer to 0. And as we plug in bigger and bigger x values, the y values are going to shoot up to infinity. So all together, this like bends upward like this, and then it bends, down like this, and this has a horizontal asymptote on the x-axis in the negative infinity direction. So now when we look at y equals e to the x, this graph looks almost exactly like this one, except the base is e, this number 2.718. So remember, e is this number. It's just a number, 2.718, very similar to 2. And so we can do the same thing. So we can make our x and our y equals, y equals e to the x. We plug in x equals 0, e to the 0, anything to the 0 is 1. So we also have that point. Then when we plug in x equals 1, we have e to the 1, which is e, which is about 2.718, right? So here's 1, here's 2, here's 3, 2.718 is, about there. And if we plug in minus 1, we have e to the minus 1, which is 1 over e, which you can think of as about 1/3, right? So minus 1, somewhere around here. And then it's going to have this same shape. So we can curve it around up like that. And it's going to have the same kind of horizontal asymptote going in the negative infinity direction. Because these ones aren't on the integer points, we should label them. So this is 1, e. And this is minus 1, 1 over e, or e to the minus 1. And those are our points on the graph. That's all we have to do. Then if we look at, so this is down here, 3 to the minus x. We're going to do the same thing. We're just going to plot this thing. So we have x and we have y equals 3 to the minus x. So now notice, first of all, that with our exponent rules, we can rewrite this as 1 over 3 to the x. So you can rewrite it that way and think about it that way if you prefer, or we can think about it as 3 to the minus x. So when we plug in x equals 0, we have 3 to the minus 0, which is just 3 to the 0, which is just 1. So again, it goes through this point 0, 1. When we plug in x equals 1, we have 3 to the minus 1, which is the same as 1/3. Right, so this is 1, 1/3. If we plug in 2, we have 3 to the minus 2, which is 1 over 3 squared, which is 1 over 9. 2, or even closer to the 0. Again, if we continue our table of values, y equals 3 to the minus x. If we plug in -1, so now notice that we have 3 to the minus 1, which is 3 to the positive 1, or just 3. So at -1, we are at 3. And at -2, we'll be at 9. So this looks exactly like the other exponential graphs, except it's decreasing as we go from left to right. And now it has a horizontal asymptote in the positive direction, going out that way forever and ever and ever. And it's a little bit steeper than the 2 to the x because now we have a base of 3, right? So 3 to the x instead of 2. And this is decreasing because of the negative sign, or because of thinking of this as 1/3 to the x. And then e to the minus x is again very, very similar, except the base is e. So x, y equals e to the minus x. So 0, again, anything to the 0 is 1. So it still goes through 0, 1. At x equals 1, it goes e to the minus 1, which is a 1 over e, which again, we'll think about as approximately equal to 1/3. So at 1, we have this point, which is 1, 1 over e. At -1, we have e to the minus 1, which is e to the positive 1, which is approximately 2.718. So when x is -1, there's 2, 3, somewhere in between. So this is the point -1, comma e. And again, it's decreasing because of that negative exponent. And again, it has this horizontal asymptote in the positive x direction. So that's e to the minus x. And then we have the log graphs. So remember, the log graphs are the reflection across the line y equals x of the exponential function with the corresponding base. So natural log of x is the inverse of e to the minus x. So if we thought about drawing in the line y equals x here, and then you put down a lot of ink and flip it over across that line, you're going to get this graph that's the natural log of x. So that's just sort of rough idea of what it should look like. And we can plot some points. So we have x and we have y equals natural log of x. So when x equals 0, natural log of 0 is undefined. We don't have anything there. Also, for any negative number, it's undefined. When we plug in x equals 1, natural log of 1 is 0. So this should also make sense. So on the graphs we saw above, right, we had this point was 0, 1. And then when you take the inverse, the x and the y switch places. So now we have 1, 0. Similarly, we had y 1, e. Now we're going to have e, 1. So that's, we don't want to really plug in 2 or 3 because we don't know what natural log of 2 or 3 is. But we can plug in e. Natural log of e is just 1. So if this is 1 and this is 2 and this is 3, e is somewhere about here. So this is e, 1. And similarly, we can try to plug in something else. So we can that we can figure out. So if we plug in e to the minus 1, which again, remember is about 1/3, natural log of e to the minus 1 is just -1. So about 1/3, we're at -1. So this is this point here, label the point itself, is e to the -1, 1. And now we have a vertical asymptote, which is the reflection across y equals x of that horizontal asymptote on the graph of y equals e to the x, and our natural log graph looks like this. Rewrite this point for us. This is e to the -1, or 1 over e, -1. That's what this point here is. And then similarly, log base 2 of x. This one's a little easier because of the integers, I think. So this is y equals log base 2 of x. Similarly, 0 or any negative number is undefined. We don't get a y value for that. If we plug in 1, log base 2 of 1 is also equal to 0. So again, we go through that point 1, 0. If we plug in x equals 2, we get 1. If we plug in x equals 4, we have log base 2 of 4, which is 2 because 2 squared is 4. Oops. So 3, 4, 1, 2. And similarly, if we plug in y equals log base 2 of x, if we plug in, not minus 1, if we plug in 1/2, y equals log base 2 of 1/2 is equal to -1. So at 1/2, we're at -1. It's 1/2 comma -1. And then just like our natural log graph, we have a vertical asymptote in the negative direction on the y-axis. So those are those graphs. I strongly recommend, as always, that you practice graphing them. Don't just look at them and say, oh yeah, I can do that, because you're probably going to make mistakes or mix things up. So make sure you practice them. Make sure you practice labeling points or going through the correct anchor points, and make sure they're curved the correct way and they're not too straight or pointy or anything like that. You can also, it might be helpful to like print out the solutions and practice tracing over it to see if you can draw the graphs well. Hope that helps, and I will see you next time.